Hi and good evening, everyone.
Good evening, sir.
Our topic for our topic for today is exploring the lunar south pole using Chandrayaan 3. And for this topic, we have Mr. Ashish Devaraj. He is SRF astrophysicist, Christ deemed to be University, Bangalore. So, without further ado, I'd request Ashish sir to start with today's session.
Yeah, good evening, everyone. I'm Ashish, and thanks for having me. It's always a pleasure to talk about Chandrayaan in front of you. So I'll share my slides now. Hope it is visible to every one of you. Can someone
So, the
confirm?
screen is visible. The screen is
Yeah.
visible.
Yes, sir, it is visible.
Okay. Let me directly go to the talk then. Is that fine? Okay. So I'm here to talk about the how Chandrayaan 3 is going to explore the lunar south pole, and I mean already explored because 14 days have already passed. And let me I'll navigate through the talk by giving you a bit of uh, an understanding about why south pole is important, why are we going to the south pole, and then what all instruments are there on Chandrayaan 3, and what all we used to do various scientific experiments there, and what was the initial results which came out in
Yes,
the
sir.
recent past. So that's how I'm going to navigate through my talk. So let's move to the first slide. So these images will be very familiar to you all, right? So the first one on the green, with the green color is a river. Right side is a glacier, and the thing given in the bottom is the ocean. So these are the forms in which Earth has water. So that's where we find a lot of water on Earth. So this is very familiar for us, and we all know about the water cycle which happens on Earth, right? When the sun heats up the ocean and evaporation happens, and that forms the cloud. Then clouds go move into colder regions, and then precipitation happens. Then that is formed as ice in form of glaciers. It is collected in ponds, rivers, and water flows back to the ocean, and then this cycle continues. This is very familiar. So now when you look at a surface like this is the surface of the moon, and which is very much rugged, and which is so dry, and the temperatures vary from 150 degrees Celsius to minus 171 200 degrees Celsius. So expecting we won't intuitively we won't expect water to happen or exist there, right? Because of the dry weather and dry temperatures and the dry images which you see. But on the contrary, this is one of the interesting slides in my presentation, which I also like. This We have a water cycle happening in the moon. Other than Even though it is a very dry area, even though the temperatures vary drastically, we have a water cycle there. So in this slide, I want you to look at three things. One is the incoming of water, how water reaches the surface of the moon. Second one, how it escapes from the surface of the moon. And third one is something very interesting, which I'll keep it for the next last part of the slide, explanation of the slide. So let's look at the first part, uh, incoming of water. Incoming of water happens through various processes, like comets can and asteroids can bring in water. Like when impacts happen, when comets come and hit on the surface of the moon, water can be brought to the surface of the moon. Second is interplanetary particles. That is, you know that the medium through which the Earth and Moon is moving is not actually very uh, clean. It's there are a lot of dust particles and everything around us. So this since earth has an atmosphere, we don't see all these dust particles falling into our atmosphere and all that. But since moon doesn't have an atmosphere, a thick atmosphere, I would say, these dust particles and micrometeorites that fall to the surface of the moon, those particles also bring in water to the surface of the moon. Second, the third one is the solar winds. The solar wind is the ions and atoms which is coming from the surface of the sun, and which moves through the solar system, and once it interacts with the moon, it forms hydroxyl ions and hydrogen water molecules and all that on the surface of the moon. And one of the sources is very much inherent to the moon itself, because earlier in the history of the moon there was volcanic activities. You know, when you look at the moon at the night sky and you see the black patches there, right? Those black patches are the basaltic regions where a lot of volcanic activity happened, and the lava flowed around the surface and froze them down. So during that time also we had a lot of water coming onto the surface. So that basaltic region which you see on the moon is actually similar to what you see on Hawaii and all that. You see black color mud forming, right? The lava flows frozen down. So those things are actually similar to what is seen on the moon. So those are the four things that are the uh, input of water, how water comes in. Then how water evaporates, or since you have a lot of temperature variations, the water molecules get enough energy to escape the atmosphere or the gravitational potential of the moon, or else the particles which is coming from the sun hits the water molecules and it again evaporates them. It's called as photodesorption, and various other processes happen. So those are the way it escapes the moon surface. But there are some molecules which remain, water molecules which remain on the surface. They have enough energy to escape the lunar surface. So that thing is shown here as called as thermal temperature driven migration. So what happens is, that's very interesting. So once the temperature is rising, the water molecules gets enough energy to get released from the surface, and then because of the gravity it falls at some different location. It's like from there it again gets a bit of temperature, it again hops and fall at different location. It's like that mechanism is called as hopping. So these water molecules, after billions of years, it's like it keeps hopping throughout the surface of the moon. That's how the water is transported on the surface of the moon. It's called as a water cycle. So some of these molecules get escaped, the other ones, some unfortunate people, I mean, or maybe I would some unfortunate water molecules or fortunate molecules, I would say, would go and reach regions where the temperature is not varying too much, where it won't get enough temperature to do this hopping process again. So those kind of regions are called as the cold trapping regions. That is shown on the right side of the moon, of this slide. So that is where water molecules get trapped, and then from there it cannot escape because there is no temperature variation happening, so that it can do the hopping process. So these cold trapping regions are mostly seen. Majority of these cold trapping regions are mostly seen at the south pole of the moon. That is where south pole becomes very interesting. If you look at the left side of the slide, you see an animation there. So that is the illumination of the sun throughout an entire month of entire lunar month, that is around 29 days. So you can see that some of the craters, if you can see my pointer, some of the craters does not receive light at all. Those are called as permanently shadowed regions. Those are actually the cold traps which I mentioned earlier. So the right side figure also shows a static figure part of the south pole. The black color regions which you see marked here are the permanently shadowed region identified at the south pole of the moon. So this is the temperatures at the south pole. I mean, this permanently shadows are extremely low, than it is less than 110 Kelvin, which will translate to around 170 degrees Celsius, minus 170 degrees Celsius. You should imagine how cold it is. Right, at 0 degrees Celsius, the water freezes to ice, form ice. Right, so at minus 170 degrees Celsius is like too cold that it cannot. The entire movement of water molecules gets frozen, and then it will be temporarily, I mean, sorry, permanently trapped inside those shadowed region. So this is where the South Pole is getting interested for the first point. The second thing is the mineralogy, the minerals which you see at the South Pole. In this slide, I want you to look at the second row, first image, which is seen in yellow, red, and bluish color. So that blue color region is particularly very interesting. That was a region which formed during the early evolution of the moon, when a huge impact, a huge asteroid came and hit the moon, and a lot of debris which was removed from that region. The color which is shown in this figure is correspond to the height uh, of the of the topology of the surface of the moon. So blue is the lower regions and red is the highest regions. So blue shows that a huge kind of basin, we call it it's a basin, which is a kind of a huge crater, was formed during that early evolution of the moon. So that debris material which was excavated from the interiors of the moon. That means if you are going deeper, means if the depth is more, means you are actually excavating the interior part of the moon, right? Which is not seen at the surface. So that interior region, which almost comes from the mantle region also, was actually distributed at the South Pole region, which made the South Pole more and more mineral rich. And that is what you see in the other figures. You will see a lot of iron there, you see a lot of titanium there, and thorium, which is used in radioactive, as a radioactive material, all which can generate energy. All those things are getting enriched, was enriched when the South Pole Atkin basin was formed. That is called, that blue region is called as the South Pole Atkin basin. So this is the second reason why South Pole is so interesting. So if you, for example, if you now we are all planning to move, I mean, build permanent settlements somewhere across, I mean, around the solar system, right? The moon will be the very closest place which we can go to. So the Artemis mission and everything from NASA is actually planning to build some science experiments, or some permanent settlements there, where scientists can go there and do experiments at the lunar atmosphere, lunar environments. So the challenge there, if you want to go to such remote places, is like for a longer duration, we can't take in resources from Earth and go there. Right? It's for a long period, and we cannot take that much of resources from Earth and go there.
Sir,
Yeah.
sir, how will they extract the resources, sir? Because they might be very deep or something.
Yeah, that is where, I mean, it can be deep, but the present understanding or the present measurements which we do, even with Chandrayaan 3, is off the surface of the moon. It's just the initial 1 or 2 meters. That much only we can go. Some methods are even restricted to the very surface of the moon, like around like 20 micron of the surface. So there are various for example, I'll give you an example to explain that. So there are, see, oxygen is a very important element for humans to survive, right? We breathe oxygen. So oxygen can be extracted from the lunar soil. There are various research happening across the world, uh, which uh, which proposes various methods, like metallurgical methods, to extract oxygen from the soil, lunar soil. So that is one of the things which is happening. So there are various processes like heating. So those methods can be used for to extract out other elements like iron, thorium, titanium, and all that. Even in the case of Earth, how do you get iron? You don't find pure iron in the mantle, right, or in the surface, right? So what we do is we do various processings after collecting iron ores, and we do various processing to extract iron. Such processes can be done there, but we'll have constraints based on the amount of energy we have, and we'll have the constraints based on all the resources which is required to do iron extraction or whatever extraction is possible. At Earth, everything is very abundantly available to us, right? See, we don't have to think about oxygen. Even now we are breathing it, and we are not aware of how much oxygen is there for us and all that. But when you go to the surface of the moon, every resource is limited. So like that, we can extract all the
Excuse me, sir.
yeah.
Sir, you mentioned earlier that the black craters or black spots we observe on the moon are basaltic regions formed due to the, you mentioned due
Yes,
to some lava formations.
yes,
Sir, but
yes, yes.
aren't they the craters formed due to meteorites or asteroids collisions on the moon's
Yeah,
surface?
okay. Yeah, I didn't explain it completely. I was just telling that there were lava flows. So when you go to the beginning of those lava flows, how did the lava flows happen? There was this period of lunar evolution where it is called as the Great Bombardment period. Okay, that is when the environment where Earth and Moon is sitting now, staying now, was actually crowded with a lot of asteroids and comets like that. So once we were orbiting the sun, a lot of debris or asteroids kept on falling onto the surface of the moon, also on the surface of the Earth. So during that period, that is called as a Great Bombardment period. So during that Great Bombardment period, uh, huge impacts happened at the places where you see the black patches now. On the When you look at the night sky, you see the black patches there. Something like this, I explained, right? South Pole African basin. So some basins
Sir,
like Imbrium basin,
sir,
such basins were formed. Okay. Yeah.
sir, on Mars they have figured out a way to make oxygen. So why can't they do that on the moon too?
On Mars, is it from the atmosphere itself, or uh,
No, sir. So in the news it had come that NASA had found out a way to like make oxygen on the Mars.
okay, so what I know about that is there were methods to trap in carbon dioxide, which is abundant on the in the atmosphere of the Mars, and that was converted. I mean, after removing the carbon, some oxygen was remained. That's one process, and other things will be like extracting it from the soil of Mars itself. Those, but since Moon does not have an atmosphere, we cannot have apply the same methods which you do there in Mars. And we'll need some other methods, which the only material which we have is the lunar soil, right, which is immediately available for us once you go there. So from that, what can be extracted, that is what research is doing now, trying to address.
Sir.
So coming back to the earlier question, which was asked about the lava flows. So when the basin was formed, when I told you, right, the large impacts happened and large basins were formed, like Imbrium Basin, other basins which you see there. So that depths were filled with lava flows which came from the interior of the moon. So that filled in lava was spread out, and that cooled and later formed uh, the basalt regions which you see. There you see a lot of iron enrichment and all that. That is why it is seen in black color. So that is how the black regions on the moon was formed. That is, you shouldn't be confusing that with the permanently shadowed region. Okay, that is thus were on the near side of the moon. Excuse me. The other part, the permanently shadowed region are the craters at the south pole, where you don't receive any light there. So these two, yeah.
Sir,
Yes,
sir, I want to
yes,
ask. We
yeah.
are talking about colonizing moon, but if we build space centers there or research labs there, then we will be exposed to the harsh conditions of the space weather, or the solar flares, the solar
Mm.
storms. So how can we do all those high tech works in that?
Okay, that's a very nice question because those conditions are very harsh. As I just mentioned about the temperature varies from 150 degrees Celsius to minus 150. Around that huge range of temperature variation is seen. And sun always bombards a lot of ions and solar what is the plasma onto the surface of the moon. That is where our experiments on Chandrayaan 3 becomes more important, because we have temperature measurements of the surface and all that done and with Chandrayaan 3, and also we are measuring the plasma atmosphere just above the surface of the moon. There are instruments which I'll talk about later in the slides. And so we need a prior understanding of what conditions we can expect when we go there. So that's why we have the Chandrayaan 3 and the other lunar missions, which is planning to go to the South Pole, is very important. So for example, if you have
Presentation went,
I
sir.
didn't
The
get your
presentation
question.
went.
No, it's there. You
Sir, actually, your presentation is not showing because I think
Oh,
you just
Sir,
started.
okay.
it's
Should
showing,
I
sir.
I'll show it again. Now is it visible?
Sir, you have to go to Teams, sir. You have to go to Google Meet and then you have to share it.
Oh, okay. One second. Google Meet. Now is it visible?
Yes, sir, the screen is visible now.
So can I continue with my?
Yeah, yeah,
Yeah.
sure.
Okay. Uh, yeah, you were talking about the plasma atmosphere there. So, based on our measurements with Chandrayaan 3 or any other lunar mission which is planning to go to the South Pole, we will know what conditions we can expect at the South Pole. So, based on that, we should build all the protective layers. Like if you are making some chamber, it should not allow all the solar material or the plasma to enter it. So the engineering should be done in such a way that all these conditions can be tackled, and a human being can stay inside that chamber safely. So that is very important. So such research is also happening in parallel. So that is that. I hope that will answer the question.
Excuse me, sir.
Yeah.
Sir, how does the temperature varies as we move on the surface of the moon?
Okay. So see, how do you get a evenly I mean, distributed climate here in Earth? Why do we get that? It is because of our atmosphere, right?
Atmosphere, yeah.
Atmosphere has all these variations, like we have all these circulations happening. So the tropic regions receive a lot of sunlight that is transported to the polar region, made it cold, and that circulations are happening throughout. That is why we are getting a stable climate or stable temperature here. We are disturbing all those things that is there, and now that's why you are getting all the global warming things, and all those cycles are getting disrupted. So on the surface of the moon, you don't have an atmosphere. So whatever sunlight you receive is actually heating up that region. That the entire temperature which you see feel is actually on the because of the sunlight. So the day side of the moon, that means where you get the sunlight, is actually having very high temperatures like 150 degrees Celsius. And on the night side of the moon, when the sunlight is off, I mean directly, the temperature drastically drops to very low temperatures, like minus 170 and all that. So uh, it's actually based on the illumination of the surface. Since
No, so
it does,
my question,
hmm, yeah,
sorry to interrupt you, sir, but my question was that as we observe a change in the temperature on
hmm,
Earth as we move further in altitudes, so does that
hmm.
happen on Moon too?
That's what I'm telling you. It's like it does not have. Why does it get? Does it have a? Why does Earth have a gradient? Because of the atmosphere, right? The particles which is there in the atmosphere is getting all the heat, and it is getting transferred here and there. It is getting evenly distributed. But in the case of moon, you don't have an atmosphere. So such a mixing of temperature is not happening. So that's why when you don't receive sunlight, you suddenly drop the temperature to very low values of less than minus 100 degrees Celsius. That is what is happening on the moon. Hope that
Okay,
answers
sir.
you.
Yes,
Yeah.
sir. Yes, sir. Thank you.
Yeah. So, yeah, I told you about the importance of South Pole. So, because and now let us look at the previous missions which happened throughout history. We started from 1966. That was the Luna 9 Russian missions. Was the first one to reach the surface of the moon. It was Luna 9, and several missions followed, like Apollo missions, where we went with human beings and we excavated the material. We brought in almost like 400 kilograms of lunar material back to Earth, which is only half of that is still analyzed, and you have another half of the lunar material which is not yet analyzed after all this 50-60 years. So the it actually opens up a lot of opportunity to study the moon. But as you can see this figure, there are no missions which has gone to the South Pole. South Pole is the downside of the figure, that of the moon. So that was when Chandrayaan 3, because that's where Chandrayaan 3 becomes very important. Chandrayaan 3 is the first instrument which was sent to the South Pole of the moon. So lander instrument which was sent to the South Pole of the moon. We have information from the orbiter satellites which goes around the moon, and which maps the South Pole of the moon. So we didn't have any in situ measurements. In situ in the sense, you go there to the surface, and with the material itself you do some analysis. Those things were not done for the South Pole. So that is where Chandrayaan 3 comes into the picture. So the South Pole
Excuse
is
me, sir.
not, yeah,
Sir, as you said that we bought 400 kilograms of lunar on Earth, and
lunar
you
material.
lunar
Yeah.
material, yeah. So you
Mm.
said that only half of that has been analyzed and half of that is still left. So
Yeah.
that would there be a variation? So that half of it shows different components and half shows different components. So
Uh, that
isn't
is
there
not
uniformity?
expected because we don't know if you analyze some new material, you can find something new. Definitely true, but it is not expected to vary too much, because we after the lunar material was bought in here and we did laboratory experiments, we had sent a different probes there, right, for orbiting the moon. So those orbiters have also in a crude manner, or in a global scale, have estimated the abundance of all these material which is present on the moon. on a global scale. So those the abundances, for example, rock forming minerals like, elements like magnesium, aluminum, silicon, iron, all those, we know how much quantity is there on the surface of the moon. So that actually matches with what experiments have, what the lunar samples have given, the results from the lunar samples. So it is not expected to change drastically, but always, as science is always brings something new, right? If you do some new experiments, so if there is possibility that there can be something new which is not yet found, or we'll be finding the same things again, that is also there. But various type of experiments can be done which is not which has not happened before. So those things are the possibilities of those lunar material. I hope that answers that question.
Yes, sir.
So yeah, now coming to back to the South Pole. South Pole, this is the South Pole of the moon, and this is where we landed. The coordinates were 16.9. You all know, probably you might have read it always on the news and all that. This is where we went with Chandrayaan 3, the lander, and we landed there, and we went on doing some experiments. So this was, you might have all seen these images. This the left side is the landing location, which this image was taken from the lander itself. It's actually a very proud moment for India, because uh, nobody has gone to the South Pole yet, right? And you are looking at the actual images which is coming from the remote region of the moon, and it is coming through our instruments, and which is very kind of inspiring for me as well, because if you need such motivation to do new work, and use all the data which is coming in and all that. On the coming back to the slide, so on the right side you see Chandrayaan 3 rover, which is about to come out, and which has come out and which is traversing on the lunar south pole. So you might have all seen these images. So now coming to the instruments, we need just going there is not enough, right? We have to perform some experiments there. So Chandrayaan 3 consisted of two parts. Okay, one was the propulsion module, and the second one was the lander. The image which you see in the on the left side is the is Chandrayaan 3 after assembling both of the propulsion module and the lander. The lander is shown at the bottom portion. So the lander is which had the propellant in that, which took which did all the orbital maneuvers around Earth, and then took the lander to the south pole of the moon. So that was all done by the propulsion module. It had a mass of 2,000 kilograms, and most of that was the propellant. So it, and since in Chandrayaan 2 also, this is Chandrayaan 3, but in Chandrayaan 2 also it was almost similar, but the propulsion module which is shown here was actually an orbiter. You had several around like 7 payloads on the propulsion on the orbiter itself, on the downward portion of, since we that Chandrayaan 2 is already active and still taking measurements, we don't have to send in the same instruments again, right? So that's why this time we did not have any instruments on the propulsion module. And we had a very interesting instrument which I'll talk about later, which is called as the shape payload. I'll come to that point later in the slides. So the propulsion module is this one. So the now coming to the lander, the top portion of the left side figure is the lander. Lander had a mission life of 1 lunar day, that was around like 14 Earth days. That we have already completed that, and it had 3 payloads on it, and also the communication devices which is required to be required to send the data what is collected on the surface of the moon to Earth, right? We had big antennas here in Bangalore and various locations on the Earth, so that we had direct communication with the lander. So lander had all the communication also. So that was the landing. And the third one is the rover which was housed inside the lander. As you can see on the left side figure, the rover was inside the lander on a on a closed slope. So once the lander successfully landed on the surface, the slope was opened, and through that slope the rover came out. That's how it happened. So that rover also had some and we had two instruments on board which would analyze the material there, which would analyze the material and understand the composition and the mineralogy of the material, of the lunar material. So it was actually kind of a mimic of a geologist on Earth. So now coming to the payloads. These are the three payloads which were there on the lander. So this left side, first one is called as the Ramba payload, which which actually measured the surface plasma, which at a particular height. So as I mentioned earlier, to understand the plasma atmosphere just above the surface, this Ramba payload was used. So there are results which is coming up. The initial results are there, and the second instrument is called as the Chaste instrument. Chaste was a rod kind of structure which had thermal sensors at different scale, different lengths. So it was probed on to a depth of 10 centimeters, and we had measurements at each centimeter gap. So that was the chassis was designed to measure the thermal properties of the lunar surface. The third one is called as the ILSA payload. ILSA is the instrument to measure the lunar seismic activity. For example, on the surface of Earth, you have a lot of earthquakes happening, and because of the tectonic activities and all that, right? And but in the case of Moon, there are no tectonic activities happening, but because of the gravity of Earth, the interior of the Moon have some frictions which causes seismic activities. Those activities can be measured using the ILSA payload. So with this ILSA payload, if you know the seismic waves, how it is traveling, how intense it is and all that, we can model the interior of the Moon, like what state it is it in a liquid form, are there multiple layers, is there a mantle there, is there a core there, what is the core made up of? Such different questions can be answered if you get the seismic, if you measure the seismic activity. So ILSA payload will help us in measuring the what is that, seismic activities on the on the moon. We actually have a tentative detection of an event, but that is not yet confirmed yet. Those are some initial results. And now coming to the rover, as I mentioned earlier, it was a mini geologist, right? So it had two instrument called as APXs and LIBS. The APXs is like is an X-ray spectrometer, which works which works based on a principle called as X-ray fluorescence. So what it does is it fires some alpha particles onto the surface of the moon and excite the induce some electronic transitions inside the elements there. So once the elements have electronic transition, it will emit out some X-ray light that is measured by a spectrometer. With that, each element will have a different signature in the spectrum. We can identify which element is what. Oxygen. Oxygen is not measured by magnesium, silicon, iron, all those elements, and then some minor elements like manganese, chromium. All elements can be measured with APX.
Sir, why not oxygen?
Yeah.
Sir, I'm saying why not oxygen? Why it can't measure oxygen?
Because see, every instrument have a energy band which it can observe. So APX covers from something called as 1 keV to 10 keV, around that. It is the low energy region, but oxygen falls in the 0.5 keV region. It's at the very edge of the spectrum. So we cannot measure that region because APXs cannot look at that region. Okay, so hope that answers. Yeah, the next payload is called as the LIBS payload. It's called as the laser-induced breakdown spectroscope. The name itself suggests that, right? You have a high energy laser which is fired onto the surface of the moon, and that generates heat and it burns the material there, forming fumes. That fumes is actually the light coming from the fumes are measured by a spectroscope, and
Sir,
that yeah.
sir, can
Yeah.
you explain like how they like shoot the laser?
How they shift the laser. Okay, this instrument is actually mounted in such a way that it faces the lunar surface, and then as the rover moves, it can sample different locations. It is not like you point the laser. It is the rover, you go and stand at some position, and there you fire the laser and get the fumes and do the measurements, and you move the rover at a different angle and you do measurements, some do repeated experiments like that. That's how otherwise the laser is not pointed at different locations. It is actually looking down.
Okay, sir. And sir, also can you share this PPT after the session?
Yeah, that can be done. That can be done. Right. Yeah, that we can do. So now coming back to the yeah, where were we? We were talking about LIBS, right? So yeah, LIBS can measure magnesium, aluminum, all the major rock forming elements of the soil in a different. So with APXs we can quantify how much is there. With LIBS you can identify what elements are there. So it is like that. So now coming to I'm particularly interested in this instrument because it's called as the shape payload. This was the one instrument which was there on the propulsion module. So the propulsion module, this instrument actually doesn't look at the moon. It looks at Earth. So see, for example, we know only one example, right? Where you have life. That is our planet, our Earth. So till now you have not found any signatures of life, direct signatures of life anywhere else in the universe. So we have been looking for a lot of things, but we have not found. So this is the only planet which we have, which harbors a life, and which brings in a lot of responsibility that we should preserve this. So now, if you want to know what signatures life on Earth makes on the atmosphere around Earth. For to look at that, payload helps us. So payload looks at the Earth and look for various spectropolarimetric signatures of which is caused due to life. So similarly, which can be extrapolated. So now if you are looking at some other planet which is on around some other star, you can look for these particular signatures there and kind of draw inferences that might be an Earth-like planet, or that there may be life. Something like that can be drawn. So this payload is kind of interesting. And
Excuse me, sir.
yeah,
Sir, does only life exhibits these polarimetric signatures, as you said?
yeah.
Nothing else can send out these signals.
You mean other signatures? Okay,
Other
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 like
other organisms or other things can't extend these signatures. Only life can.
yeah, organisms are basically life itself. So we are looking. We don't know what results will come out of this because this is the first time somebody is doing a polarimetric experiment on Earth. So we will analyze the data. I mean, not me particularly, the payload team and also people who are interested in this kind of measurements will do the analysis and look for. We need further understanding about this because we should know what signature it can make and what we are seeing, and those things will come up later after we receive after the data is analyzed thoroughly. So life can produce such signatures. That's what we understand now, and how much we can detect them is a question. And we'll see how the data from shape payload is coming out to be. That is that I can only openly leave it because we don't know much about it. I hope that answers the
Yes,
question.
sir. Thank you, sir.
So that is shape payload. This is particularly interesting to see how has come out. So now let's look at some initial results from Chandrayaan. So you have I mentioned about SAS statement. Right? The red figure is showing the y-axis. The axis is the perpendicular axis, and the x-axis is the depth, and the y-axis is the x-axis is the temperature. So this is in millimeters. So 0 corresponds to the surface of the moon, and minus 20 will be 2 centimeters, minus 40 will be 4 centimeters, like that till 8 centimeters. So we have probed till 8 centimeters down in the surface of the moon. So now look, this is very interesting. So at the surface you see around like 50 degrees Celsius. If you look at the plot, you see around 50 degrees Celsius, and by just probing by by 8 centimeters below the surface, the temperature drops drastically to minus 10 degrees Celsius. That is a huge drop. So these are initial results. We need to do all the thorough analysis on this, but the initial results also suggest that if the temperature drops so low like this within a very small depth itself, uh, maybe we can the surface of the moon can hold more water than we thought earlier it would, because at minus 10 degrees Celsius and all that, water can freeze, right? And which maybe we can find some subsurface water content also. That is just a possibility which is coming into my mind. So these measurements can lead to such results also. So this is one of the initial
Sir,
results. Yeah.
sir, does it also convey that moon lacks a core or a mantle?
How do you how did you think about that? I mean, I
Sir,
didn't.
I think because as the temperature is decreasing within a short range of depth, so does that convey that moon does not have a hot surface inside something hot to keep it?
Okay. Like that. Maybe it see, okay, this is just 8 centimeters, and the crust of the moon crosses around 30 kilometers. Okay, so that is that 30 kilometers and 8 centimeters has a lot of difference, right? So we can't say that the mantle is coming out. And also we have seen that the moon is more or less not very active in case of volcanism. We don't know how much heat is there in the mantle material which can heat up the surface. And also there is one more mechanism which can heat up the surface, is called as radioactivity. So in earth also a lot of radioactivity happens underneath the surface of the earth, and which keeps the earth warm. So maybe this can suggest that this is again coming into my mind just now. I'm not which can be an initial interpretation. If the temperatures are very low, maybe we are not seeing a lot of radioactivity happening at the very initial, I mean, the very subsurface of the moon. So that can also cause the temperatures to drop very drastically, because that is an alternative source than the sunlight, which can heat up the surface of the moon. So many results can be derived. So these are very initial things. Yeah, hope that
Okay.
answers. Yeah.
So you told that by measuring the seismic activity on the surface of the moon, we will
Yeah.
come to know about the core and mantle. But my question is, the seismic waves is formed by the tectonic plates. So how can we know about the core by measuring the seismic activity?
Okay. Um, Okay, just to correct you, the moonquakes are not formed due to tectonic activities. It is because of the gravity which Earth exerts on the moon. So various movements happens interior of the moon. That is what is seen as seismic waves in the surface. I mean, what we measure there. So to answer your question, to know whether there is a core, a solid core, for example, there are two types of seismic waves. Okay, the one is called as S waves and P waves. So both these waves can be measured, and those two waves acts differently based on the density of the material. So, for example, uh, I'm not okay. I think the P waves penetrates through the depths of the moon, and you can get information at different depths. So, but the S waves, once it reaches a different density, it bounces back. So those kind of things can brought into models and see, and based on the measurements of these waves, we can model the interior of the moon. We cannot directly measure. We can from the seismic activity or the seismic waves which we measure, we can interpret what kind of state the core is and what dimension it is. Such measurements, such modeling can be done. That is how it is done for Earth also. We measure the seismic waves, and then see, you have that images, right, where you show the core and the mantle material, and you know the depth of the mantle, how extended it is, and how large the core is. Those measurements are actually coming from modeling based on the seismic wave situation.
Okay.
So
Thank
hope that answers your question.
thank you.
Now coming to the Ramba results. So Ramba was measuring the subsurface plasma density. So it's measured around 5 to 30 million electrons per cubic. That is the measure of plasma. Plasma is actually electrons or ions. Okay, so the density of that is, when you see take a cubic meter of volume, you have 5 to 30 million electrons, which is like very low when compared to Earth and all that, because Earth has a magnetic field also, which actually protects us from all this high density plasma which is coming in. But since Moon does not have that, it is actually reaching the surface. But what initial measurements is giving is that this is a very low density plasma, and 5 to 30 million electrons per cubic meter is only measured. So these are initial results. We need further checks on this to confirm all the results. Now, coming to the other three, I have already mentioned this in my previous slide, APXS and LIPS. There was this interesting confirmation of presence of sulfur in the lunar material. That was the first time which we detected sulfur. But again, these are very initial results. We need further uh, and further analysis, deep analysis for to confirm all the presence of all the elements and also measure the quantity of how much it is there and all that. So in ILSA also we have recorded a seemingly natural event that also needs further clarifications and further analysis to understand it. So we have one recording of an event, but yeah, that is also an initial result. So this was the
Sir, what
latest.
is seemingly natural?
Okay, there can be two type of when for example, if you are standing on the ground and a heavy vehicle passes through, you will feel the vibration, right? So
Yes, sir.
similarly, when rover was going around on the surface, it will cause some very low vibrations on the surface of the moon. That was detected by ILSA. Okay, that is actually artificially made, right? So naturally made signals can also be measured, and on top of that, you have artificial signals also. So that's why I told seemingly natural, because seemingly comes because this is not very confirmed that it is natural, but it looks, the initial profile of the that seismic wave looked like a natural event.
So,
But
sir,
we need.
ELSA was to measure the natural seismic activity, natural vibrations of the moon, but it measured the artificial vibrations, right?
It can see once the rover was moving, that's what we need. We have coordinated observations, right? So the rover will be kept stationary when ILSA measures the seismic activity. So at that time we don't have any other disturbances which is artificially coming. So that will if an event happen, natural event happens at that point, ILSA will be measuring the natural event. Okay, so now when the rover is moving, you have an artificial vibration happening there. So that is also measured, but that is a different thing.
That is not considered, right?
That is not considered natural, because it's because of the rover, right? That is an artificial thing.
Yes, sir.
So natural
Understood, sir.
things,
Thank you.
yeah, that's what it is. So these are all, I want to again emphasize that these are all very initial results, and further analysis is needed to confirm all these things. So
Excuse me, sir.
yeah,
Sir, could you please explain how the rover was deployed from the lander and how it was placed in the lander?
okay. And for that, I'll have to go back. No, yeah, here, okay. I want you to look at the left side figure on the left side. Okay, that golden bigger structure is the lander, and it had a cavity on one side where the rover can be fixed. Okay, rover was actually placed on this black color ramp, right, like structure, and it was
Sir, which
folded.
means it was vertically upright while
Yes,
it was in the lander.
while it was in the lander. And once the lander landed and the slope deployed, it was it came horizontal, and then it slowly uh, uh, moved through the ramp and went to the surface. That's how it happened. There are videos of
Got
this.
it.
You can find it online also. Maybe you can look at that and have a picture of how it happened.
So in the wheels, rocker bogie mechanism is used.
Yes, I don't know about the technicalities of those things, but it can have 360-degree movements. Like it moves, it can rotate like this on a single axis. Such movements was possible by the rover.
Okay, got it, sir. Thank you.
Yeah. So now going back to the latest updates. So we were see, because of the drastic conditions there, temperatures variations and all that, it is very difficult for any instrument or any electronics to survive that harsh conditions. For it to survive, we need to give additional heating mechanisms and keep the instruments warm enough so that uh, during the next observation you can bring back the instruments. But since unfortunately we did not have any such arrangements in Chandrayaan 3, we were limited to observe only for the for one lunar day, that is 14 Earth days. So we recently, today and yesterday was the attempts which was done. We after the first initial observations, we it went to lunar night, right? It went to through all the harsh conditions, Chandrayaan 3, and then now today and yesterday we tried to wake it up, expecting or hoping that the instruments will work. But till now, we have not found any signals from the rover or lander. But they are still trying for it. Today's 23rd, and not any other updates have come from ISRO. So this was the last update which came. So still, we have not received any signal. Hopefully, we'll.
Sir,
Yeah.
sir,
Yeah.
sir, I have heard that many space agencies are trying to bring helium-3 from moon to Earth, but I want to know that why helium-3 is so much important. Means what is its significance in our life? Means why we need it?
Okay. That I'm also not very sure about. Where did you read this that they are bringing in helium?
Yeah,
Because helium is available on Earth, and it is actually a very,
there's
uh, very
three.
sparse. I mean, very
Yeah,
minor element in the case of moon. Okay,
I heard that it's a isotope of helium, which is helium-3, but
uh,
I'm not sure that why they're so much eager to bring it on Earth. But I read in it on an article.
okay. I'm not sure. I have, but helium have. I'm not able to think about anything now, but I have
So
not
it
come
will be
across.
used for nuclear fusion related researches.
Okay, helium. Why can't we make it here itself? Is there any explanation for that? That's what
So
I
it
would.
is rare
That
on Earth and it is abundant on Moon, that is why.
Okay, helium is rare on Earth.
I am. I heard that
So
helium.
helium-3 isotope.
Yeah.
Okay.
Why is why that isotope is so much important? Helium is here, helium-2, but they are saying helium-3 is most abundant on moon surface and we need it on Earth. But I don't know why we need helium-3 here.
I'm sorry. I'm also not aware of that. So
Okay, sir,
I'm
no
unable
problem,
to.
no
So
problem.
yeah, but we are planning to bring in other rare earth elements also,
Yeah.
which is not available that much on Earth. That can be done. I mean, in future once all these missions will go and have sample returns. We'll have. Okay, this was the final update, and yeah, I don't want to forget about Chandrayaan 2 because Chandrayaan 2 was the predecessor of Chandrayaan 3, and Chandrayaan 2 is still active, and it is giving a lot of beautiful data which is coming to us. And I'm particularly working on Chandrayaan 2 data, and this is one of the figure taken by an OHRC camera, high resolution camera, which is on board Chandrayaan 2. Sorry, Chandrayaan. That camera is actually having a resolution. One pixel in this image is 30 centimeters, cross 30 centimeter. So it is we can identify objects which is of that dimension using the high resolution camera which is on Chandrayaan 2, which is one of the highest resolution cameras ever sent to the moon. So it is still active, and this was one of the figure taken of the landing site, and you can spot the lander there using the YHRC images. So with that, I would like to stop the talk,
Sir,
and thank you all for listening. Yeah.
Sir, is the lander of Chandrayaan 2 also active? In space
No,
orbit?
that's what we actually was not very successful in landing the Chandrayaan 2 rover lander, right? That's why we attempted Chandrayaan 3. So
Yes.
that was the lander fail was in orbit till, I mean, in the predicted orbit till around like 1 kilometer or so, but beyond that we couldn't control the lander, and it crash landed on the surface. So that is not
So, sir,
active.
basically, it's a scrap now on the surface of Moon.
Yes. Yeah. So that's it from my end. You can ask more questions. We can have an interaction session.
Okay, if anybody is having any other questions, please ask.
Sir,
What is the reason behind the crater formation and why all the craters has a circular shape?
Okay. Okay. Crater formation happens when asteroids collide with the surface of the moon. Okay. So now assume I'll give you an example of an analog. Okay. So assume that you have a still water, a surface of water, and you are dropping a drop of water onto the surface, or onto that. You will see that the waves are moving in a circular fashion, right? So similarly, similar principles apply there. So once this asteroid moves to gets falls on the surface, it uh, spreads energy in all directions. That is why it is forming a circular like shape. That also depends on which angle it is hitting and all that. So it is actually based on that. Hope that answers the question.
But why it is on the moon? Why it is on the Mars? It's not possible.
Mars also has craters.
But
It is
all the craters had not circular shape as the moon have.
okay. Now, okay, that there comes the importance of an atmosphere. Okay, for example, our Earth also had suffered a lot of cratering. That means a lot of impacts had happened, but now we don't see any signatures of that. We see signatures, but that is also very much changed, right? Because of the atmospheric processes, water cycles happening here. Earth is a very active planet. Similarly, Mars also have atmosphere. It has its own way of activities happening there. So all the craters which was formed there will get transformed into other forms. But in the case of Moon, it does not have an atmosphere. It does not have that such processes. And once the crater is formed, the only process which will degrade it is the solar influx or other cratering happening, the secondary cratering happening. Also, the processes which makes them disappear from the surface is now absent on the surface of the moon. That's why we see and it is present on the surface of Mars. So that's why we see craters on the moon and we don't see them particularly. Very evident craters like moon on Mars. I hope that answers your question.
And I have another question.
Okay.
You were talking about the low plasma density
Yeah.
on the moon surface.
What I didn't get your question. Can
For
you repeat it
plasma
again?
formation, temperature
Mm.
should be high.
Okay. Yeah, this is actually not the plasma which is formed in situ. That means it is not heating up the material there and forming plasma. Radiation is very less, I would say, and the majority of the plasma which you measure is actually coming from the sun, the solar plasma, which is reaching the surface. So it is not sun is all that plasma is already heated. So that is what is measured by the payload. Hope that answers.
Okay, sir. Thank you, sir.
Sir,
Yeah.
I have heard that billions of years ago, a planet of the size of Mars hit Earth, which is called Theia, and the
Hmm.
existence of Moon came. But I want to know that is there any real life rock solid proof that there was a coalition and there are some craters made on Earth or some great damages which will prove that the Moon is really made from the collision of Theia.
Okay. So I'll answer that, and the measure based on the measurements which we have done on the surface of the moon and the surface of the moon, Earth. So there are something called as isotopic measurements, which identifies which isotope of atom is there and all that. So what we have seen is that Earth and Moon has been formed by the same isotopic materials. So when you check oxygen and all that, the same oxygen isotope is found on Moon. So and there are several other things also which support the the same mineralogy which you see, and the deficiency of iron and all that are actually uh, observations, and based on that we have a hypothesis that some collision happened and the same material which was on Earth actually went into orbit and formed the moon. So people say that this is not very, I don't know whether this is true, but I have read that the Pacific Ocean, which we have on Earth, is actually a very huge crater region, right? So that material which was present there was actually transferred to the moon. The collision happened in that region. That's what. This is not. I don't know whether it is a very scientific thing because I have not read that in any way in scientific papers. But there are talks which happen in that direction also.
Okay, sir. Okay,
Hope
sir.
that answers.
Sir, I have another question.
Okay.
Sir, it's not directly related to Chandrayaan 3, but a little bit of side question. It's like the one spacecraft we heard that Voyager 1, which went very far from Earth, but still gave information till a great distance. Means how can
Okay.
that much distance is there, but still the information can travel? Means here we can see that the connectivity of our phones or other devices are limited to a specific distance, but that is very long.
Yeah, true. That is true. Now I'll tell. Okay, we use radio signals to communicate with any spacecraft. Okay, so these radio signals get attenuated because of atmosphere and other material or atoms which is present in the path. Okay, so since the space is more or less empty, the attenuation of these signals are relatively low in space. Okay, so but it will take a particular amount of time. For example, it takes around 1 second to for light to travel uh, from moon to earth. Similarly, so if you are sending a radio signal from moon, it will take 1 second and reach earth. So if you are at a distance of very large distance like Voyager, it can also transmit the same energy, but you have to transmit a bit more energy because you are traveling. I mean, the signal should travel a lot of distance, but the attenuation in space is so it is low, so it does not require a lot of energy, but and but it takes a lot of time to reach us because it has traveled a farther distance, right? Light can only travel up to 3 lakh kilometers per second. So based on the distance, it will take more time to reach the surface of the earth, and we need to receive it, but it is possible. That's what I would say.
Okay. Okay.
So, sir, can't we use these radio waves in our homes for connectivity?
I didn't get your question. Can you repeat it?
sir, I am saying that as you said, the radio waves are used for connecting with any spacecraft. So, sir,
Huh.
can't we use these radio waves for connecting our Earth?
Connecting Earth. Okay.
Yes, sir.
Okay. Yeah, I'll ask you a question back. How do you get your call on your phone? Those are all radio waves.
Also,
How do you
that the
communicate
Bluetooth, that
with
the Bluetooth has a
the
limited range.
hmm?
The Bluetooths have limited range, right? So, can't we
Blue?
replace them?
Okay, so see, that is based on what is required, right? If you want to transmit something for a long distance, Bluetooth will not work. If you want to transmit something in a very shorter distance, Bluetooth will work. And for example, the Wi-Fi signals which you receive, those are all radio signals, at different bands of radio wavebands. So Wi-Fi, the mobile signals which you get from the tower, all the communications happen which from the satellite which is on around the Earth. Everything happens using radio signals at different bands. You might have heard about 2G band, 4G band. Those are all different frequency ranges in the radio band. Hope that
Okay,
answers you.
okay, sir.
Good evening, sir. May I ask my doubt?
Yeah, sure.
So, like, means I was just means 1 or 2 days earlier, I was just researching about the deep space network made by NASA. So, like,
Okay.
means they are using their this deep space network for like communication with the many of the satellites, which are new satellites, which are
Mhm.
like going means to Moon or Mars. So, like,
Mm.
is does India has any means disadvantage of not having like that system?
I would like to correct you because India have deep space networks.
Yes,
Uh,
not like yeah.
Yeah,
Yes.
India have deep space network. It is called as IDSN,
Yes.
Indian Deep Space Network. And there are multiple antennas, which is one is there in Mauritius. We have something in Andaman and Nicobar Islands, and we have something in Bangalore. And all these antennas are used for deep space communications.
Yes, sir.
That's
But
what Chandrayaan is actually using the deep space communication of India itself.
yes, sir.
Yeah.
Okay, sir. Thank you, sir. I didn't knew that new information. So sorry.
Okay. Okay. That's it.
I don't think that anyone is having any other queries or doubts.
Okay.
Thank you,
So,
Ashish sir, for this wonderful
okay,
session.
okay, yeah. So
And
let's,
thank you to everybody else present in this meeting. And if you want to have more sessions like this, please comment down the topics that you want the sessions on. And once again, thank you everyone for joining on this call. Thank you. Have a nice day.
thank you so much for having me also.
Sir, the
Yeah,
PPT can you share?
yeah, that I can transfer it to the organizers and then we see.
Thank you, sir. Sir, can we leave?
Hello, sir.
Yeah. Yes.
Hello. Sir, what do you think about Chandrayaan 3 wake up or not?
What do you think? What I think? That's what you're saying.
Yes, yes.
It is. It's actually. I want to be hopeful, but the thing is, the conditions are there at the moon are very harsh. So the chances of getting back the instruments is very low. That it did not. I mean, many of the instruments which were sent earlier also by other countries were not able to come back. Only one of the instrument which was sent there, I think it was from the Chinese group, was able to revive back after the lunar night. So chances are slim, but I want to be hopeful. That's what I'm saying.
Okay, sir. Thank you, sir.
Okay. If yeah, the, if there are no more questions, can we end the meeting?
I don't think that there are any more questions.
Yeah.
Okay, I have noted everyone's point, like on what topics you guys want the webinars. I'm just sending a link, so just so that you guys can be updated. Just join our community, WhatsApp community. You will be updated over there. Thank you once again, sir,
Okay.
for giving us this wonderful session.
I hope it was informative for all of you and you all understood something.
Surely, sir.
You took away something from my talk. And thank you for having me.
Oh, surely, sir. Thank you.